Very good morning, everyone. So today I'm going to start with the chemical bonding, the new series, and in which you will get to know about different concept about the matter and its physical and chemical properties. Even we also get to know about the bonding of the atoms, covalent bonds, ionic bonds, their polarity, the relationship between the electronegativity, and many more things. So I hope you will enjoy this video and you will get better base things even to start with for the chemical bonding. So I'll start with a very basic definition, that is chemistry. And chemistry is a branch of science which deals with the properties and physical and chemical properties of the matter. What is matter? Matter is something which occupies space and volume. And secondly, matter can exist in three different forms: solid, liquid, and gaseous. So whatever the changes it undergoes by natural laws or any other chemical reaction, we will see in the chemistry. Chemistry is of two types. In one is inorganic chemistry and another is organic chemistry. In inorganic chemistry, we will deal with the inorganic compounds and organic organometallic compounds, their structure, their behavior towards the chemical reaction. But in organic chemistry, we mainly discuss about the carbon-based molecules. Even the first molecule that we have isolated is from living organism. So which is contained carbon. As we are as a body, we are having carbon, hydrogen, and oxygen in our body. So to differentiate between organic and inorganic chemistry, so I'll have some differences. Like organic chemistry will deal with the organic compounds. Like this is organic compounds. But inorganic chemistry deals with the inorganic compound. So in which if I'll talk about inorganic compounds, they contain hydrocarbons. They will have carbon and hydrogen, and as well as oxygen can also be the part. In inorganic compounds, they don't have this. They have ionic base like NaCl or any crystal, that is NaCl and MgCl2. So something which is present in an ionic or lattice form. And in organic chemistry, it represents whatever the reaction is, it depends upon the functional group present in the compound. Like suppose we are having OH, means they are alcohol, aldehyde group, or oic acid, that is ethanoic, or you can say COH carboxylic acid group. But here they require acid-base reaction, displacement reaction, redox reaction, etc. In organic chemistry, we deals with the oils, fat, sugars, but inorganic chemistry deals with the salts and crystals. Because they are having carbon, hydrogen, oxygen, they boil and melt very easily. But inorganic compound, no, because they are crystals, they are closely packed crystals, and because of that, they are having higher melting point and degrade instead of boiling. So this was a little bit difference between organic chemistry and inorganic chemistry. So I'll start with the very basics. So suppose this is a table. Table is just an object. An object is made up of atom. So basically, what is an atom? Atom is a particle of matter that uniquely defines a chemical element. Suppose this is a crystal lattice. All these are our atoms. If they all atoms of chlorine, they can be hydrogen. So this particular atom will, uniquely defines a chemical element. So in this crystal lattice, all these purple color, they are atoms. And here if you will see what are atoms, something is having positive charge, something is having negative charge, and somebody doesn't have any charge. So we will look into it. So whosoever is not having, don't have any charge, so we will say they are neutrons. But these are the positive, they are protons, and these are the electrons. Here, if you will see, neutron and protons both are being concentrated in this space. Okay, and the electrons, they revolve in a particular orbit. This is called orbit. Okay, so here what we have learned, that electrons which are revolving in a particular direction and in a particular orbit, and this neutron and the protons, they are concentrated in a particular space that is called nucleus. So we will say electrons, they are negatively charged particles, and they are having atomic masses of 9.109 into 10 to the power minus 31 kg. With proton, they are having positive charge and which are present in the nucleus. Okay, and having atomic uh, mass is 1.67 into 10 to the power minus 27 kg. And neutrons, they are subatomic particles that are one of the primary constituent of atomic nuclei, which is neutral. Means they are not positive, neither positive nor negative. So having atomic number is 1.6742949804 into 10 to the power minus 27 kg. So the question is how atoms was discovered, or the how we get to know that what is nucleus, what is the location of like everything. So there is some chemical bonding theories are there. So first model was proposed by J.J. Thomson. So he said that atom is look like this pudding. This whole pudding is having positive charge, but these cherries or the because the chocolate crumbs are negatively charged. So they said this is whole atom. So J.J. Thomson just given them one model in which you can check. But Rutherford was the another scientist who given the experiment explanation that he said these suppose this is light source of alpha particles. This is a golden flow. So when he is passing alpha particle of positively charged alpha particles on this gold foil, so most of the alpha particle get transmitted. That means when somebody can pass, when there is a space, that means they said in an atom, the whole space is empty. Not all atom is, spread by the positive charge. And most of will get deflected back. Here, one some are reflected by some small angle and some by large angle. That means something is there which is positive. Here the reflection is there. Other part is empty, but something is here which is something is there in the concentrated part. So according to the Rutherford, he said electrons revolve in a one fixed orbit that is called orbit. Okay, but the positive charge is concentrated in a one place that is called nucleus. So to get it, yes, some particles are there. They use one fluorescent screen on which they will get the particle size that yes, something is there. Bohr model was proposed by Niels Bohr. He said yes, electrons revolve around the nucleus in a stable orbit without emission of radiation. Means if there's a one or nucleus, this is one orbit, second like this. This is K shell, M shell, L, M like this. So this is a nucleus. Electrons are revolving here in a fixed path. If electron will jump from lower energy state to higher energy state, then you can say they required energy. Or if they are coming from higher energy to lower, then they have to emit the energy. But if they are in a same orbital, they will not emit any radiant energy. So each orbit has definite energy we call them as energy shells or energy level, or we can define them as K, L, M, N shells. So we can also, correlate this model with this formula. L is the angular momentum, N is the principal quantum number, which tell you about in which shell that electron is present. H is the Planck's constant, 2 pi. So that I was talking about, that this is a nucleus, first shell, second, third, and fourth. So positive charge in the nucleus, but electron revolve in a particular shell. Now, we have already talked about that element is made up of atom and of same atoms, same type of atom. So how we will calculate atomic number and atomic masses. So this is a symbol, guys. Suppose if I'm saying this is a oxygen and atomic number is 8, atomic mass is 16. That means 8 is Z. We can represent it as a Z. And this 16 is represented by E. A means atomic mass. Please remember, atomic mass is the addition of proton and neutron, but this Z is the proton. And very important, protons are equal to neutron because we said atom is electrically neutral. Means how many number of protons is equal to how many number of electrons. They both are, if suppose in oxygen, number of protons are 8. Electrons will also be 8, but neutrons 16 minus 8, like this. Then we will get 8. Okay. So these terms are also very important to understand the elements. So some chemical elements, they have same atomic number, but atomic masses are different. We call them isotopes. They almost have same identical physical and chemical properties. But in isobars, they don't have same atomic number, but atomic masses are same. Because of the atomic masses they are same, they have different physical and chemical properties. In case of your isotones, in case of isotones, they are having different number of neutrons. How we can say? Suppose in the lithium, 3 atomic number, 7 is atomic mass. So proton, how many proton is there? 3. 3 is a proton, but neutron is 7 minus 3. It is 4. And in beryllium, this one, in this case, 4, 8 minus 4, 4. Neutrons are 4 in both the cases. So this is how isotones have different physical and chemical property. They have same number of neutrons. That's why we call as isotones. This term iso means here same. Here atomic number is same, atomic mass is same, number of neutron is same. So let's come to the point, the bonding theories that we have to learn about before, because atoms are there, they connect with each other by some bond. They can be covalent bond, they can be, it can be, ionic bond, it can be coordinate bond, different type of bonding will be there. But how they will combine, how they will attach themselves to get the stability, that we will study in this next video. So here, the bonding is something that makes the atoms to get stabilized by making molecules. So to understand how and why atom attach together and in which manner they do so, that is an important part of the chemistry. First of all, we should have the understanding of bonding, because we can predict the shape of the molecules, because how they will bond, what type of the properties they will get. So we can also design or build new molecules with particular set of chemical and physical properties. So first question can anybody ask, but why atoms they form bonds? because they want to be, everybody in this universe wants stability. In a periodic table, every atom is trying to possess noble gas configuration. So most of the stable arrangement of the electron in atom is to have either they can fill the valence shell or to have 8 valence shell. This is called octet rule. According to the octet rule, atom should to get have noble gas configuration. They should have 8 electrons in the valence shell. So atom obtain this stable electronic configuration by sharing. They can gain or they can lose the electron. So that's why which creates the chemical bonds between the different molecules and the same atoms or the different atoms. Okay. So before bonding, you should have the knowledge of three things. Who are metals, metalloids, and non-metals. Metal are those which have characteristic chemical and physical properties like iron, aluminium, copper. They have different properties. The metals have luster, they are malleable, ductile, but non-metals, they form negative ions by gaining or accepting electrons. They are called non-metals. Okay, so non-metals, they have a capability to gain or accept the electrons. Basically, it means I can say that non-metals are electronegative in nature. They can attract the electron pair. Okay. So like carbon, nitrogen, this is the P block of your P block of periodic table, where carbon, nitrogen, oxygen, sulfur, they all are there. But metalloids, they show the properties of both metal and non-metal. So that's why we call them metalloids. They're antimony, germanium, silicon, arsenic, they all are metalloids. So if you will see this periodic table, we say all this is S block, and this is P block, and this is D block, and this is F block. Like so, they are saying that they are electropositive in nature. They are mostly metals, and they are non-metals, and metalloids are these. So metals are found to be left of the metalloid. These are the metalloids. So these are the metals. Okay. And on the right of the metalloids, we will get the non-metals and in between metalloids. Now, as we are talking about metals and non-metal in the P block, so these two terms are very important to know about. One is ionization energy. Basically, ionization energy is that energy which is required to remove the valence electron from the outermost shell in the, when the atom is in the gaseous state. So metals have low ionization energy. Metals have low ionization energy, but non-metals have high ionization energy. Why? In the previous periodic table, these carbon, nitrogen, oxygen, they are very near to the noble gas configuration. Like fluorine require only 1 electron to get stable. Oxygen want 2 electron. Like this, nitrogen want 3 electron, carbon want 4 electron. So as they are going right towards it, their electron activity is getting increases. Okay, so and mostly size is getting decreased. So I'll show you. Similarly, the because of the electron activity, they are having a property to steal the electron from the other atom. Metals have low electron activity, but non-metals have high electron activity. So when you will go down in the product table, size is increasing, valence electron is there, far from nucleus, so easily be get removed. That's why here ionization energy is less. But here in this case, very small uh, in comparison to this. Size is small, nucleus is very close, electron is very close, no more energy is required to remove the electrons. So we can't do that in this case. So in a periodic table, when we are going from left to right, electron activity increases. Okay. Okay. So I hope you get get the basic idea behind what is chemistry, what is atom, and metalloids, metal, and what about the periodic table. So we will in my next video I'll start with this Lewis dot structure of the atom. This will be the chemical bonding part 2, and stay tuned to my videos, and definitely I'll go further one by one Lewis dot structure, and after that ionic bond, covalent bond, dipole-dipole interaction, everything I will discuss. So thank you guys. So I will see you in my next video. Thank you so much.